Okay, good morning, guys, or afternoon, or whatever time of day you happen to be listening to this. This is Miss Abner, and we are going to go over 1.4 reasonings and proof for geometry. Up until this point, we've learned some things, but right now we're going to focus on your essential question, which is how do you go about proving a statement? So this is essentially making your logical arguments for stuff. So the first thing we are going to look at is going to be our essential question. So the essential question is what you should be able to do at the end of the lesson. So in this case, how do you go about proving a statement? So we should be able to prove a statement at the end of this. So let's go ahead and look at the first part of our tools to prove. And that's going to be this whole section of things that we're going to go over right now. So the first thing we're going to look at is a conjecture. A conjecture is a statement that is believed to be true. So just solely because it's there, we're going to take it as truth and we're going to operate as such. So we're going to say, okay, because it's a conjecture, then we're going to believe that that statement is true. On the other hand, a postulate or postulates are statements that you accept as true. So you just know that somebody else did the work and they've proven it, so you're just going to take that as what's true. These are going to normally be your rules in geometry, are usually postulates. You also have theorems, which is a statement that you can prove is true using a series of logical steps. Now, in this case, it must have the steps of proof. If it doesn't have the steps of proof, then it's not a theorem, because you couldn't logically get there, meaning that you couldn't walk from one place to the other and follow the math. So if up until this point you've had math teachers and things and they've explained things to you, and if you couldn't follow the math or they're looking at your work and they couldn't follow the math, then sometimes you get a question wrong. So this is the following the math part. For a theorem, you have to be able to follow the math to get to the answer in order to prove that it's true. Okay. So then we're going to have counterexamples. Now, a counterexample is an example that shows that a conjecture, so this is something that we remember, this is something that we previously believed to be true, we're proving it false. And the conjecture, like I said, was what we had previously believed to be true. But there has to be an example that shows that your conjecture is false. Okay. If we're talking about a deductive structure, so your deductive structure or a system of thought where statements I feel like that doesn't fit, so hold on a sec. Let's see where it is. I'll write it different, but it'll fit. Statements are justified by previously assumed or proved conclusions. I would say proven because proved sounds kind of silly. So conclusions. Now, these are the things that we're going to take note of with this. So we're going to say previously assumed. Let's take a second look at that. So through this process, we kind of assumed that certain things were true. So we're going to point out the things that we previously assumed were true. So things that were previously assumed were our conjectures, and our postulates, or when we get more into the proofs, you'll see things that are just straight given to you. And because it's given, we assume that it's true. So if you're doing deductive structure, you have to make sure that your statements were justified by something that was previously given. So you're looking at the step above. Or we're going to look at, so these are the previously assumed or the things that you proved. So the things that you proved, so the things that we proved would be our theorems, and our counterexamples. Okay, so we just want to make sure that we understand when it says previously assumed that we're talking about a conjuncture or a postulate or a given, and we want to know that when they're talking about something that we proved, these are going to be our theorems or our counterexamples. Okay, now we're ready to put some stuff to work. So let's look at the next part of your notes. So we're going to complete the steps to make a conjecture about the sum of 3 consecutive numbers. If you've taken a math class before, I don't know, last year, maybe algebra 1. Okay, we are going to look at our consecutive counting numbers. So consecutive means in order. So these are our counting numbers that are in order. So numbers that are in order, an example of that would be like, I don't know, 1, 2, 3. But it doesn't have to just be 1, 2, 3. It can also be 5, 6, 7. It's just numbers that are in order. So they're asking you for number 1, write a sum that represents the first 3 consecutive counting numbers starting with 1. So first off, they gave us where we start at. So they told us that we're going to start here at 1. So down here, because this is where we're at, we are going to start at 1. So now I'm going to say, all right, well, consecutive numbers from 1. And it said it wants the first 3 consecutive numbers. So 1, 2, and 3. And it wants a sum. We're going to point out the fact that it wants a sum, because that tells me whether I'm adding, subtracting, multiplying, or dividing. Sum means that I'm going to add. So I'm going to go ahead and add them together. And addition goes from left to right. So we're going to add 1 plus 2, which gives me 3, and plus 3, which gives me 6. That should be mental math for you. So if they're asking you for the sum of the first 3 consecutive integers starting at 1, your solution should be 6. So it says, is the sum divisible by 3? Well, the way we find out if something is divisible by 3, we just divide it by 3. So our next step, we're going to go 6 divided by 3. Well, do we get a whole number out of that? Well, we know that there's 2 3s and 6, so we get a 2. And so then, yes, it is divisible by 3. Notice that my answer has 2 parts. The part where I prove it, here, there's me proving it, and then here is my answer. Because it didn't tell me divided by 3, and what's the answer? It said, is the sum divisible by 3? So then what I did was, well, let me check it. That's all that proofs are, it's just you checking it and then telling what happens next. So yes, I checked it here in the box, and then the answer was yes, it was divisible by 3 because a whole number came out. If it was a fraction, then it's not divisible by 3. Okay, now let's look at the next part. It says, write the sum of the next 3 consecutive counting numbers starting with 2. So now it's going to give us another go round on it. And this time it says it wants us to start at 2. And it wants 3 consecutive counting numbers, and we're starting with 2. What are they asking for this time? Again, they want a sum, which means we're adding again. So let's go 2, 3, 4. And we are adding again. So let's go in here and add. Well, 2 plus 3, because we're going left to right, rules of addition. So 2 plus 3 is going to be 5. Well, then 5 plus 4 is definitely going to be 9. Okay, so now that I have my answer to that part, that answers the first question. Now it says, is the sum divisible by 3? So same thing we did before. I'm going to take that 9, which is my sum, and I'm going to divide it by 3. Well, when I divide 9 by 3, well, there are 3 3s in 9, so I end up with 3. So here's my proving it. And then since a whole number came out, that means, yes, it is divisible by 3. Okay, now it says complete the conjecture. So the blank of 3 consecutive numbers is divisible by blank. Well, the sum, remember, our 2 yellows were sum, so the sum of 3 consecutive counting numbers is divisible by, well, what number were we dividing by? Let's go back and look. Just changing color to make sure we know what we're looking at. Let's go with super bright blue. Okay, so we divided by 3 here. Then we divided by 3 here. So we have to say that the 3 consecutive counting numbers is divisible by 3. One too hard, didn't break much of a sweat, light mental math. Okay, so let's look at the next thing they're asking us to do. So it says use deductive reasoning to prove that the sum of 3 consecutive counting numbers is divisible by 3. Well, if we flip our paper over, we know that deductive structure, so we could say that that's deductive reasoning, is a system of thought where statements are justified by previously assumed or proven conclusions. So let's take a look. Let the 3 consecutive counting numbers be represented by n plus 1, and, well, let's look at our 3 consecutive counting numbers. So 1, 2, 3 are consecutive counting numbers. Okay, if 1, 2, and 3 are consecutive counting numbers, if this one we replace with n, well, this is n plus 1, because 1 plus 1 is 2. Well, so if I use n again, it has to be plus what? So 1 plus what equals 3? Well, 2. These are my 3 representations, so that we have now n plus 1, and on this line, we are going to drop in n plus 2. Now that I have all 3 of them, could I combine them? Well, I could. So the next step says the sum of the 3 consecutive counting numbers can be written as 3n plus what? Well, we're identifying from the problem before, so we have 1, 2, 3 n's. Well, there's my 3 n's. Well, what do I have left then? So then I have plus 1 and plus 2. Well, 1 plus 2 is what? Oh, well, 3, of course. Why, thank you. There's your 3. So you can write it as 1, 2, 3. You can write it as n plus 1, and n plus 2. Or you can write it as 3n plus 3. Those are all the same things. They're all congruent statements. They all say exactly the same thing. It's just 3 representations for it. Okay, so now we're going to look at the expression. So number 8 says the expression 3n plus 3 can be factored as 3. Oh, they want us to do reverse distribution. Sounds like a plan to us because we're masters. So let's go ahead and do us some reverse distribution. So since we're going to do a new skill, I'm going to change colors so that we know where we're looking at. And I think I'm going to go with a lighter blue. Doesn't matter. Miss Abner just changes colors all the time. Makes math fun. So we're going to take this and we're going to take this right here. Highlight. That's what I'm doing. Okay. We're going to take this right here and we're going to factor it. Well, from algebra 1, we know that we can reverse distribute. So if I pull out a 3, well, what does it leave behind? So in this case, the first number here, if I pull out a 3, I'm left with n plus, well, something. Well, 3 divided by 3 gives me a 1. So it's then saying that this statement here and this statement here are exactly the same thing. They're just written a little bit differently. And we know that because we factored out the 3. That comes from your factoring unit in Algebra 1. It was towards the end of the year, so it might be a really long time for you now because of that long extended break we had, but we're going to go back and revisit that. So this is what factoring is. We pulled the 3 out of both and left behind what was left because that was what was multiplied together. If you need a refresher, reach out to your teacher. If I'm your teacher, hey, hit me up. We got this. Okay, so the expression 3 times n plus 1, so we're jumped down, so we're down at the bottom now. Let's make a couple. Okay, so the expression 3 times n plus 1 is divisible by blank for all values of n. Well, if we can take 3 out, right? Then that's going to be divisible by 3 because we're going to divide, we can divide 3 out every time. So since we can divide 3 out every time, it's divisible by 3. Okay, so dividing 3 out is my little side note. Then it is divisible by 3. Okay, so now we're going to recall. That means think about what we saw before. Recall the conjecture in step E. So step E says, was there a step E in here? Okay. I think we're looking at step. Okay, it's not labeled, but we're talking about this step right here. The sum of 3 consecutive counting. So let's make sure everybody's on the same page. So we're talking about this right here. The sum of 3 consecutive counting numbers is divisible by 3. Okay, so then we're going to look at all of our steps in our deductive reasoning. So we're going to look at all of our steps here. So we're looking at our steps here. Okay, and so we have our statement, we look at our steps, and is the conjecture true or false? So is that statement true or false? Is it always going to be divisible by 3? Well, as long as that 3 sits out front here, we can factor out that 3, then yes, it's true. So no pain, no gain, we're good to go. So now that we've gotten the first 2 parts of the notes done, I don't want to make this an egregiously long video. So I'm going to start the second page of the notes on a separate video. So see you next video.